3, f of g of x looks like f of x squared because g of x is equal to x squared. So we replace the g of x, and now we are evaluating the f of x function for x squared. So that's going to look like the square root of x squared plus 4. So I have replaced the x in my f of x function with x squared, and I cannot simplify any further, so this is my solution. Now if we look at the composition of g of f of x, we are going to get g of the f of x function is square root of x plus 4, which is going to end up looking like, when we take square root of x plus 4 and we plug that in to our g of x function, it's going to look like something squared. It's going to be the square root of x plus 4 squared. So, the square root of x plus 4 squared. And we know that the square root and the square operation are inverses of one another, and that's going to leave us with x plus 4 as my solution. For number 5, f of g of x looks like f of x to the 6th power, which means that you plug x to the 6th power in for x on the f of x function. So it's going to look like x to the 6th power, all raised to the 2/3 power. And if you remember your multiplication rules for exponents, you can distribute this 2/3 in and multiply times 6, and that's going to give you x to the 4th power. For g of f of x, it's going to look like g of x to the 2/3. When we plug in x to the 2/3 for the g of x function, it's going to look like x to the 2/3 all raised to the 6th. And again, same rules apply, and we're going to get x to the 4th power.